Welcome everybody to the Trends for the Future series, Energy Harvesting and Storage. I'm Fabrizio Tubertini, I'm business developer for the Graphene flagship with regards to energy, and I'm a technology transfer manager at Istituto Italiano di Tecnologia. Please join us if you want to talk about energy today, and we have three guests. We have Stefan Koller from Varta, Maher El-Kadi from Nanotech Energy, and Sebastian Pohlmann from Skeleton, but soon they will tell you directly why they're here and what interesting project they are working on related to graphene, and not only that, probably. I'm very interested in the three different stories we're going to listen, because I know a bit better Stefan, as we have been working on projects together for a few years now. Even if I'm not a researcher and I have that kind of background, but I've been involved with their project within the flagship, and so I know better what they carry on. But I'm very puzzled also from Sebastian and Maher and what they can tell us. Also, Maher is connected from Los Angeles, so because he's the farthest one, I will start with him if you don't mind, guys. So. We finish a bit early, can go and have his cup of coffee. So thank you, Maher, for joining us, and the stage is yours.
Well, thank you, Fabrizio. I think this is a very good opportunity here for Nanotech Energy to present our activities that we have around the graphene and how we utilize them to make some more changing solutions here for energy storage and also for harvesting. So Nanotech Energy is basically utilizing the superior electronic structure and electrochemical properties of graphene to make for lithium-ion batteries stronger and safer lithium-ion batteries and advanced lithium-ion and lithium sulfur batteries. So our manufacturing facilities are research and development facilities are located in California. We have so far completed about 4 rounds of fundraising with total funding about $100 million. And we are planning to use this money here to speed up our international expansion, including opening up a European headquarters in Amsterdam and building a new high volume manufacturing facility in Reno, Nevada for the manufacturing of graphene and for the manufacturing of graphene batteries. And lastly, we're also using this to expand our existing facility in California. So the company is only 7 years old, but our interest in graphene goes back in time to more than 20 years ago. In fact, the story behind it is kind of interesting. So at the time, Professor Richard Kainer is also a co-founder of Nanotech Energy and also a professor at UCLA. He made some initial trials for making single-layer graphite, which we now know as graphene. That was in the early 2000s, we talk about the year 2000 specifically. So at the time, carbon nanotubes were making the news. Carbon nanotubes are very strong, stronger than steel. So researchers were utilizing carbon nanotubes to do reinforcement for polymers. So the problem with carbon nanotubes, they're one-dimensional in nature. So Professor Tom Hahn was a friend of Professor Richard Kainer, and also a professor at UCLA, made some theoretical calculations that indicated that carbon nanotubes can only do reinforcement in one direction. But if you need the ultimate mechanical strength for polymers, you really need two-dimensional carbon. And that was basically graphene. So that was how we got started working graphene in the year 2000. Professor Richard Kainer and his team, within about 2 years, developed a process making graphene using intercalation chemistry, published the work in the Journal of Science in 2003, and we actually own a patent on the process from the year 2002. That's actually 2 years from before the seminal work done by Novi Zolotandine that earned the Nobel Prize in Physics. We're all familiar with this Scotch tape experiments and what happened afterwards. So, so this patent is actually part of Nanotech Energy, and we're ever since actually been trying to come up with methods for producing graphene, mass producing graphene, and utilizing it in different applications. So batteries, like I said, is our main focus. Lithium-ion batteries is an essential component in everyday life. We have them in our pockets, we have them in cell phones, laptop computers, cameras, electric cars now, and even stationary applications. So lithium-ion batteries are really important, but they have one significant issue. They have safety concerns. They are very flammable. If you have a manufacturing defect, if you overcharge the batteries, they can catch on fire easily. So we utilize graphene to make batteries that are safer, that can store more charge than traditional lithium-ion batteries, and combine this also with special and proprietary electrolytes and separators to make that happen. Besides batteries, we have about 4 other manufacturing lines that utilize the fascinating properties of graphene for the manufacture of conductive inks for printed electronics. Printed electronics is making news, over the last decade or so. So we're making conductive inks with tunable electronic and mechanical properties that can be applied using a wide range of coating techniques. We're also making conductive adhesives, thinking about epoxy, 1-part and 2-part epoxy adhesives that are also using the graphene to improve their mechanical strengths and to make them very conductive. We're talking about a replacement for the soldering, which is the standard process that is widely used here for the manufacturing of printed circuit boards. So conductive adhesives here, they actually cure at room temperature. So unlike the soldering, which requires very high temperatures here, this works at room temperature, mechanically very strong. Another line for EMI shielding. So basically the purpose of this is to protect sensitive electronic devices from electromagnetic and radio frequency interference. So traditional techniques use metal screens to do that kind of protection, but we are developing here about 4 major products that are sprayable pins. These can actually be sprayed on any kind of device that you want to protect from radiation, and they do have very good shielding efficiency. We're talking about 60 to 90 decibel, which is equivalent to shielding of about 99.9999% of efficiency of shielding. Lastly, we have the graphene. We offer it for the rest of the industry for people to utilize it in their manufacturing lines. So we offer it in powders and dispersions, water-based, solvent-based, and we also have custom dispersion program in which we basically work with our customers to develop solutions for their specific applications. So that's basically about Nanotech Energy. So besides my work at Nanotech Energy as Chief Scientific Officer and co-founder for the company, I'm also an active researcher in academia. I'm a researcher at UCLA, where basically we're trying to work on new materials and devices systems to address challenges in energy storage and also energy harvesting. This is about energy harvesting too. So we did a lot of work around solar cells and also around triboelectric nanogenerators to basically harvest ambient mechanical energy to convert them to electricity and utilize them in a wide range of applications, including powering implantable medical devices in the body, like cardiac pacemakers, and also the deep brain stimulators. So this is something that we're very interested in. We did a lot of research around this too. Also, in addition to that, we work around the production of hydrogen fuels here using catalysts based on graphene and non-platinum, non-precious metals, basically for the electrochemical production of hydrogen using cheap methods here. So this is another way that we're trying to utilize graphene here to make for energy conversion and energy storage. So with that, I hope that I just give a quick overview of our activities, what we do at Nanotech Energy, and personally about what I do at UCLA as well.
Thank you very much, Meher. It's been very clear and very, very interesting. And I think also to see companies in different stages of their life, it's interesting with regards to new materials and to the energy world, which is going to be the leading factor of the change in humanity for the next 15, 20 years for sure, because we all understood that if we don't change our way to consume and produce energy, we will impact deeply on the planet. So I would skip on to Stefan, who's in a more established company, but as well interesting as in a position to tell us, from your point of view, how you're facing this innovation through graphene in the world of energy. Please, Stefan.
Well, more established. Vata is actually the oldest battery manufacturer in the world with more than 130 years of history. Today Vata has a quite broad product range, starting from small think air batteries for hearing aid application, going to small button-shaped lithium-ion batteries that you will find in every premium true wireless ear headset on the market, and also larger batteries that go into automotive application, into power tools, in the area of home and gardening, e-bikes, as meaning non-automotive electromobility. We have also a business segment that is dealing with not only cells, but rather battery packs for those customers who do not want only to buy cells, but rather a full battery pack, like the Miele vacuum cleaner battery packs from Vata. And then you have classical alkaline batteries, and of course also energy storage systems for renewable energy. private households, but also larger one for industrial applications. What Water does in the flagship is we want to utilize the graphene to make silicon as a new active material in the lithium-ion battery come to commercial application. The point with the silicon is it gives you on the one hand the possibility to do an increase of about 20 to 30% in energy density, but it comes along with a few major disadvantages. In contrast to the commonly used graphite, you have quite high volume changes of about 300%. And here, the graphene helps us on the one hand to prevent corrosion reactions with the electrolyte, and on the other hand, to keep a conductive network, because for the reaction of such an active material, you need always lithium ions and electrons. And here the aim in the project that we have in the graphene flagship, the Spearhead project, the Greenbud project, is together with partners from the whole value chain, starting from material manufacturers like Wacker, graphene manufacturers like Bidimensional. We have very good R&D institution with CA who's doing electrolyte development. And of course, we have also the end user with BMW on board. And here we want to facilitate this new graphene silicon technology for the automotive application. To be true, at the moment, we're not yet there to fulfill the cycling stability demand of the automotive application, but we are already in the range that you need for consumer application. For the future, I'm pretty confident that we will meet the automotive requirements of about 1,000 cycles and to use the graphene silicon technology not only for consumer but also for automotive applications. So this was a brief summary on the company Water itself. Sorry, what I forgot, I'm a professional chemist. I'm managing director of Water Innovation, who is doing the advanced development for the Water Group. And the Greenbud is a very good example for that, what we do with scout new material and process technologies, further develop them and bring them to a commercial application, and then the mother company, the product development team there, the upscaling, market introduction, and all of the subsequent exploitation.
Excellent. Thank you very much, Stefan. I would like to point out to the friends listening to us who are not familiar with the Graphene flagship, what Stefan just mentioned about the Spearhead projects. Basically, within the flagship, there are a few projects called Spearheads, which are the most advanced we can offer currently to the research applied to the industry. And Varta belongs to one of these main projects. And as you heard from the names of the other companies Stefan mentioned, we try to put together the research, the applied research, and the end user in real applications. And this is the aim of the flagship. And at the moment, apart from the pandemic that slow everything down a bit, we are just over half of our path of 10 years long since when was incepted the Graphene flagship itself. So we start to see results which are every day closer to hit the market. And it's very interesting now to pass on the stage to Sebastian, because we have another company, which is a new company, joined this magic world, but based in Europe. So with a different starting point from the US-based company. So I'm very interested to listen to what you're going to tell us about your story, Sebastian.
Yeah, thank you for the nice introduction. So, yeah, I work for Skeleton Technologies. Skeleton Technologies is a little bit older, but also still quite young. We are 12 years old, founded in 2009 in Estonia. And our story actually also begins from the material side. So in 2009, the technology was already there. It was in the lab. And our technology is called curved graphene. Now, the physicists already have their hands up and say curved graphene is not graphene. Graphene is always flat. And they are right in that sense. And what we have developed and what the company is based on is our curved graphene material that is has the properties of graphene in terms of conductivity. So it provides very high conductivity, much higher than any other carbon that is used on the market in ultracapacitors, which Skeleton produces. That curved graphene still provides very good processability. So it is not that you have some graphene platelets and some solution, but you can use it in an electrode slurry, like you can use activated carbon in an electrode slurry or battery materials, and you can actually have very high concentrations in a stable solution. That's the strong suit of curved graphene. So it can be used in the traditional electrode casting techniques that you use in the energy storage technology. So what the Skeleton Technologies do with curved graphene? In 2009, the company was founded after a couple of years of discussion, actually, what to do with this material. And what was decided to do was to build autocapacitors, to build energy storage devices, which are not like batteries, but they are much more powerful. They are much safer. They do not burn. They do not have any thermal runaway. They can be charged and discharged a million times and more, but they lack energy density. And what curved graphene does in these devices, it improves the energy density. What you may have recently seen if you follow us on LinkedIn or social media is that we have recently launched our second generation products with curved graphene in them, and that increases the energy density for autocapacitors by 70%, which is the largest increase in energy density in the industry since it actually was born around 25 years ago. So that is in a nutshell what we do. What have we achieved in the meantime? So in 2009, Skeleton were a couple of people in an Estonian office in Tartu. Today we have over 200 people. We have an industrialized manufacturing facility in Germany, close to Dresden, actually, in a small town called Großröhrsdorf, where we produce autocapacitor electrode cells, modules, and turnkey solution systems for our customers. We have by now also been able to acquire blue chip customers in our portfolio, such as Skoda Electric and Medcom for trams, or where autocapacitors are used for energy recuperation, but also large industrial companies for grid storage. So wherever you need tens of megawatts for a couple of seconds, autocapacitors are used in these applications. And that is a very fast growing market due to the introduction of renewables into our energy grids, where autocapacitors can really provide these power peaks to stabilize grids. We also were able to enter the automotive market in 2019. We got the first nomination for an automotive project. In that light, we also got quite recently IATF certified, which is a big step into the automotive market. And we use curved graphene in not only in our second generation of autocapacitors, but also in our third generation technology, which is called super battery, which uses the properties of curved graphene combined with a specialized cell chemistry in order to reach much higher energy density still than achievable with autocapacitors. Here we talk about 60-65 watt hours per kilogram and more, while keeping very high power. So it's exactly to fill that gap where the high power lithium-ion batteries are not powerful enough, but the autocapacitors are not energy dense enough. And that is the future as we see it of energy storage, to fill these niches that are currently not being filled, but also to not to try to provide one solution that fits it all, but to have solutions, energy storage solutions for the different use cases. So we still see, even if we now launch the generation 3, we still see quite a big market for the classic autocapacitors in all these applications where you need high power peaks for a second or 2 seconds, or even a couple of 100 milliseconds only, which are actually a lot of applications. They're just applications that you don't encounter in your daily life. However, they ensure that the lights don't go out and the lights don't flicker. So that is a relevant topic for the future. And yeah, today, as I said, we have 2 locations actually, one in Tallinn, where we still have a large office, and we still have our electronic engineering design, our module development, our systems development there, our software design as well. Whereas in Großwörsdorf, we have our cell development, our cell production, and the whole systems and module production as well. Maybe a couple of words also to what I do in the company. I joined actually 6 years ago, first as an engineer. When I joined, we had 45 people on board. I was the second person in the German part of the company to join. Today we have over 100 people actually in Germany, more than half of the company. And I then led the development of the material and the cell for some time, after which in 2020, I moved more into a strategic position of business development. And now I focus actually on the automotive market.
Thank you very much. It's all very interesting. I didn't expect your company to be so old already. It's such a new name to me that I thought you were a lot younger.
I'm trying.
Yeah. I think we have a good sample of what it means to be in business with energy at large. And I have a question for you, Meher, which is not a technical question, but I think it's very helpful also for our business listeners. Like, how was difficult or easier to convince investors to actually put money in this kind of venture in the US? Because in Europe, it's still pretty hard when we talk about new materials to convince investors to be happy to invest and bet on the future of energy, maybe on graphene. So I'm quite curious to know if you can share some stories about that with us, please.
Yeah, sure. So I think the way to get money here is to not just speak about the materials properties and what you can do, but actually show them what you can achieve with them. And I think that's how we were able to raise some money here in the US for a graphene-based technology. So like I said, we have utilized graphene here to make for batteries that are really safe, batteries that can store more charge than traditional lithium-ion batteries. We're talking about lithium-ion batteries basically are storing typically about 400 to like 600 watt-hours per liter, but we have batteries that can actually be much higher than 600 watt-hours per liter. So we're talking about batteries that basically are much more powerful than traditional ones, and they're also much safer. Something that, as with the adoption of batteries in electric cars, the market is really booming nowadays, is going very quickly. So, but with that, there are some challenges around there. You probably are familiar with the news that the GV Volt had lots of battery fires recently, to the point that General Motors actually decided that they'll be halting the production of the GV Volt for some time until they figure out what's going wrong here with the batteries. So safety of the batteries here really is a significant issue. It's not just how much charge you can store here in the battery. So we have actually utilized graphene to make the batteries to be a lot more safe. And in fact, we've exposed the batteries to multiple abuse test conditions and found that, showed that we can actually make them a lot safer and just non-flammable compared to the traditional flammable lithium-ion batteries. So I think that's the key, is to basically show people what you can achieve with them. When we first, made the first samples of graphene, like in the year 2000 at UCLA, and Nanotech Energy spin out of UCLA. So basically, we're talking about grams and milligrams of material, so very small quantities. One thing that was also kind of interesting is basically how to move from the small scale to the large scale, and we did it in multiple steps. And within about 2 years, when the company was founded in 2014, we did spend the first 2 years doing some initial experiments at UCLA, but then afterwards we had a brilliant person, the name is Scott Lane. He's our chief operations officer. He joined in, and then we were able within 2 years to actually scale up our process to make graphene in very large quantities, trying to make sure that it maintains the properties or the intrinsic properties in the individual layers of carbon, and that when we scale, that we don't lose these properties of graphene. That was very kind of challenging for us for a number of years, but we believe that we have solved that now, and we do offer graphene with fascinating electronic structural properties, extremely high surface area as well. So it's ideal basically for energy storage applications, talking about graphene here is storing charge at the interface and the surface of the material. So the more surface you have, the more charge you can store. So besides batteries, we were able to actually have multiple other manufacturing lines based on graphene, where we actually made the product stronger and more powerful. So conductive adhesives, for example, we were able to utilize graphene to make the silver-based adhesives combined with graphene to make them a lot more conductive and mechanically stronger. So it made a big difference here, and we didn't have to use much graphene to make that happen. Same thing applies to EMI shielding products that we made them sprayable, and it's basically very different from traditional approach. We have, metal screens to provide the protection, from the EMI waves, but we actually made them sprayable, so you can actually spray them around complex shapes. Because if you just have flat screens, you can only apply them on flat surfaces. But then if you have complex shapes and you want to provide some protection for that, you need paints that you can spray coat onto these complex objects. And this is what we've actually done also with graphene, and we're able to achieve extremely high shielding efficiency, which again was convincing enough to investors that we are up to something here. And I think that's the key, show people what you can achieve.
Very, very interesting. Thank you very much for sharing that. Before to go on with the more sharing of stories and innovation, I would like to point out to our listeners that they can ask questions, as Alexandra did a minute ago, in our chat. So if you have questions for our speakers, we can, see your written request and try to address it if it's of common interest. To be honest, we heard this question before with Stefan, because it was actually asked in a different session, and Alexandra is reposting this for us, I guess. And it's about battery safety, which is during its life cycle, which is a major issue that we're all aware about. And so the question is the environmental safety with graphene or with these new materials, how we expect it to be. Is going to be a better output for the environment to use these new materials in batteries? What is your opinion, Stefan?
Well, yeah, basically, when we introduce or develop new products, we also thinking already on a recycling concept, or what will happen with the batteries at the end of their life. I would say that graphene will not have a major impact on the recyclability of lithium-ion batteries. It won't make it better, but it also won't worsen it. So at the end, it will be more or less the same, because in that regard, it's not too different to the common used carbon black. What we think maybe is that silicon as an anode material will ease the whole thing a little bit more compared to graphite. But of course, this is something that needs at the end to be demonstrated on a large scale also, not only in the lab.
Thank you. I would like to point out that obviously within the Graphene flagship, we're very keen to talk about also about the possible effect of graphene on environment at large. And so we actually have proper work packages dedicated to assess the impact of graphene on different aspects. And so far, I would say that the results are very encouraging at the end of the day. So
maybe I could comment here on another aspect.
Sure.
As we see it today, graphene seems to be an enabler for silicon batteries and also enlarging the lifetime. So it means what I presented in my presentation, if you have 60% more lifetime, of course, at the end, this gives you a large added value for the environment, because the battery stays 60% longer in the field, and all the energy that was consumed for manufacturing and so on is divided through a much larger number of cycles. And therefore, the environmental footprint for these high energy batteries that have a longer cycle life should become much better compared to state-of-the-art technologies.
That's exactly true. Thank you very much.
it's also exactly what I thought, that if you have a battery that is 60% longer in life, it means less batteries are produced, and it means in the end also you need to recycle less batteries. So why per battery you might not have an easier way to recycle it, you overall need to recycle less batteries.
Yeah, exactly.
Yeah, I think that's the bottom line. Yeah, yeah. And Sebastian, as you live in like in a business world where you are an established company in a way, but still a newcomer for the business, what kind of difficulties do you find when you are, proposing new solutions to companies that are very hard to change their own mind? Like we all keen about electric cars, but when you talk to the automotive industry, they already would like to know what kind of battery they are going to put on the car in the next 10 years. So they won't change their mind very, very easily, even if they tell a story to the market, which is slightly different. So I would like to know what is the experience you have in that field, please.
Yeah, sure. So from our experience, today we are in a much better position than we were 5 years ago in that regard, especially when we just had started producing our products, or even before that. Of course, it is very difficult to convince somebody to use that new technology if you don't have any customer cases to present yourself with to begin with. So it's kind of the hen-egg issue as a young company, yeah, you don't have customer cases to present, so new customers are already wary whether they should try it out, and then they should be the guinea pig for that new technology. So that is something that we overcame by really looking at lighthouse projects and looking at younger companies that are equally agile and equally flexible as we were at the time. And with that approach, we managed to enter, I would call it the blue chip market, yeah, so with like larger companies in 2017, 2018. And since then, we were actually able to triple our revenue every year. That is also because ultracapacitors in general have gotten more attention on the market. But you're right that there are market segments, such as the automotive market, that are very, very careful in choosing a new technology and evaluating all aspects, and also wanting to know what is the long-term strategy, what can we get in 5 years and in 10 years out of this. And actually, in the case of electric cars, starting around 7 years before you will see the car on the market, to think what kind of energy storage will go into it. That development cycle is, I would say, shortening in that industry as well, because there are so many advances in these couple of years that of course these companies also want to take advantage of that. But the one thing that I think we have on our side, or we have always had on our side when convincing companies, is that we produce our own material, and thus we know a lot about the material itself. We know how to modify it, and we are not dependent on any other material supplier. So we were always able to answer questions in detail about what will happen in 5 years and what will happen in 10 years. And we're not dependent on the moods of any supplier in that sense. Yeah. That is one point, and the other point is that with this integrated value chain of being your own material supplier, comes a lot of innovation potential. So innovation is not only like what Maha already said, having just nice material is not innovation. Innovation is bringing the material into the application and showing what value brings it, and that also brings you investment. That has been definitely our advantage, not only with investors, but especially with these companies as well.
Thank you. That's a very interesting point of view, also because the material issue is a well-known issue within the Graphene flagship. Like one of our teams is working on standardization of the graphene itself, like to define graphene, because as you well know, graphene, it's an empty word for on the commercial side of it. It could mean anything. So before to try to answer also another question that came in in the chat, which is related to biographene. I would like to know from Maher, who's just about to approach the European market, if I understand correctly, what actually pushed you to cross the Atlantic and come over to Europe to offer your products?
Yes, so we are in active talks with basically automakers for electric cars. A lot of them are based in Europe, and we're coordinating efforts here to make for batteries for electric car applications. That's why I'm going to enter the European market, but probably starting with smaller applications for our graphene products as well. So not too much to say about it because a lot of it is actually proprietary and cannot mention specific examples, but I think this is our next step here.
Okay, cool. And is anybody interested in this question about biographene? Because to me sounds quite new, but I understand that somebody's starting to be sensible about how we obtain graphite first and then graphene. But I think the way we obtain graphite is more relevant at the moment. I don't know if any of you has feedback on this biographene issue.
I can comment from the ultracapacitor industry perspective, because it's not graphene, but one of the materials that is used mostly in ultracapacitors today is activated carbon made from biological sources, which are mostly coconut shells. And the one issue with these things, why it's very it's of course a very nice source, because it's mostly green, and I would even say getting that carbon into ultracapacitors is better than just letting that carbon escape through compostation basically of this organic waste. However, the one big issue is with this is that you are dependent on this randomized property that you normally have in organic samples and biologic samples. So I would say it very much depends on whether your process in the end is scalable. So I don't know much about the biographene from corn, but if it's made from corn husks and not from the actual corn, that's a good start. And if then the process is scalable and the process is actually provides a product that is stable, then I would say it has potential. But that goes for any carbon material.
Sure, depending also on the energy you need to actually obtain the material, because we have seen a few studies coming also from Australia, if I recall correctly, which are pretty interesting, but energy-wise are not exactly savers, let's put it that way.
And one of the biggest issues I would always say is purity, because you always have a lot of heteroatoms in these sources. So you need to, in the end, to have more cleaning steps, and these increase the energy consumption, increase the price as well. Yeah.
And Stefan, sorry. Yes, please.
I just wanted to add one more point here regarding the recycling of graphene. And basically, just from a perspective of the lithium-ion battery industry, for example, so graphene and other carbons basically is not the problem. I think it's just the lithium metal oxides that people are utilizing, heavily in the cathodes is actually what causes the problems. And right now, there's active research in academia where people are trying to use non-metal-based cathodes for lithium-ion batteries that can be a lot safer. So, but carbons, graphite, activated carbon, graphene, is part of the nature, and its detrimental effects are not as bad as that of the other metal oxides, and some of these metals can actually be toxic and can be very expensive too. Regarding the cycling of graphite itself, even from lithium-ion batteries, like a spent lithium-ion battery, people have even showed that you can get that graphite electrode from the battery. That's at the end of the life of the battery. And then so use that as a precursor to make graphene, and then basically use it again in batteries. So you can have a process that is completely recyclable here and safer, not throwing it into here the landfill. So I think graphene and other carbon materials are going to be basically environmentally, the impact here is just going to be very little compared to the other toxic materials that other people are trying to use in the batteries here.
Thank you very much. We all expect that as well. I was saying, Stefan, could you just tell us what are the advantages from your point of view, or being part of a large initiative like the Graphene flagship, as you've been long-standing with it?
Of course. Well, to be true, it is a big network that is very professionally managed, and this gives you, as a company like we are, a very good platform to do the R&D, because you have there all major players in Europe in it, and otherwise you need, with a lot of effort, to search for them, to select them, and there you have all already together, and this was and is for us and will be for us a big advantage.
Thank you. At the moment, I think we are currently about 170 entities between research institutes and companies. Unfortunately, also this year has been a phygital event, or more digital than phygital actually. But hopefully next year we will be able to converge to a physical place and start meeting again, because the Graphene Week, it's it's the most popular event within the Graphene initiative, the Graphene flagship initiative, and it's really an excellent moment to match academia with the business as well, and also meeting physically people that might give you ideas and connections, as Stefan was mentioning before, to find the right path to move on along the graphene innovation. And also the funds that the Graphene flagship has have been spent wisely so far, and this has been also certified by the European Union. But projects are also well sustained when they are crucial to applications. And obviously, having so many potential applications of graphene doesn't really help to focus on one single solution. But on the other hand, the community at large, it's really interesting. And I can say that in Europe, the graphene scientific community is very strong, actually, apart from the fact that we have the fathers of graphene in UK. But it's a good starting point, and it's a very close community and cooperating a lot. And I've noticed that during this last 12 to 18 months of pandemic, research is one of the few things that actually managed to go ahead without stopping. Everybody has been slowing down a bit, but we didn't have a real stop like in the economy. And now, especially in Europe, but in other countries, there are different and similar solutions to be applied with the PNRR plan. So the plan of the European Community to relaunch economy. We all expect to have a new push towards applied research. So even if it won't come exactly through the flagship, we will see more occasions to partially finance with the European Community funds the research and push this towards the market. And there is no doubt that the battery world at large and energy world in Europe is going to be crucial, because we can't be squashing between Asia and the US for being dependent for this source. So it's very important that we find new technologies to be applied on the European soil, and to have industries which are advanced in the energy field based in Europe, or at least having the production in Europe, even if not everything is European based, if it's not possible. And probably we're also able to fill up the gap about raw materials, which at the moment are an issue as well, because not all of them, but we have many raw materials that we can rely upon also in Europe with regards to new technologies and application of new technologies. So all this is a very big challenge. So there are only a few minutes left. Now, can you comment? I read the last question, then we see. But before we go, I start thanking my guests, so Stefan, Maher, and Sebastian. And I tell you that obviously you will have the program continuing in our hub, so in the Graphene hub. So once this Zoom call is finished, you have more fun joining us in over calls on other parts. And the very last question, and you can close on with a small chat about this, is can you comment on the Panasonic Graphene battery? I have a story, but I won't tell my story, but if you feel like you can comment on it. I've seen a Kickstarter project that has Panasonic batteries mentioning there is graphene in it, and then when you call Panasonic to have the profile, it's quite vague where the graphene is. But this is my personal experience. I don't want to spoil you the answer from our guests. So Sebastian, do you have any news about the Panasonic Magic batteries?
I have no news about that particular battery, to be honest.
We are waiting for them. Maher, in the US, you have special news?
Well, to be honest as well, not much to know about this, but basically a lot of people are trying to utilize the properties of graphene to make for better batteries. People are trying to introduce them into anode, into cathodes, to basically reduce the resistance of the cells and be able to make something that's faster charging, improve the cycle life of the batteries, make them safer. I think from all aspects, people are trying to make batteries better and safer and better for our life. So I think that's what's going on, and I guess Panasonic is going after fast charging capabilities. So yeah, that's one aspect that a lot of people want in the consumer electronics industry.
I won't ask Stefan because he's a direct competitor, so I don't want to put you in a position to answer dangerous question. But I have pictures from friends who went to China a couple of years ago to a fair completely dedicated to graphene, and they came back with gadgets of all sorts, graphene-based officially. And so I think graphene, it's an interesting word at the moment, and we have seen also startups and spin-offs, raising a lot of money based on like interesting ideas and a little bit more. So I think to have a scientific approach, a serious approach, and being part of this big family, which is the Graphene flagship, is also helping for your own reputation and help our own reputation to talk seriously about this matter and trying to offer serious solutions to a market and not just riding the horse of easy money on graphene-based solutions that don't really exist or were just claimed. This is not with regards to the latest batteries we're talking about, but in general, we can see many things like, tennis rackets or, paddle rackets, which are the latest fashion with this magic material, and you don't know what is actually doing to the racket to enhance your performance, but people buy it. So I'm happy for that. Well, thank you very much. Our time is over. I look forward to meet you again in person somehow in future. And thank you very much for the time you spent with us. Thanks a lot.